Welcome to Study Loop.
Let's analyze the process during the acceleration part of his chin-up. The distance traveled during the acceleration part is half the total distance, which is 0.15 meters. The time it takes to do the accelerating part is half the total time, so it's 0.5 seconds. And then the initial velocity is equal to 0. And so we can use these initial conditions along with the kinematic equation that y minus y naught is equal to v naught t plus 1/2 at squared. And we can use this to solve for a. When we do that, we get an acceleration value of 1.2 meters per second squared during the acceleration upwards. Now let's draw a force diagram. We have the applied force of the arms pulling the body up, gravity m times g pulling the body down. We can also write this as the weight, since the problem gives not the mass but the weight, so this is more convenient. And then we also have an acceleration upwards during this time. And so if I call straight up positive y, then Newton's second law gives me force minus weight is equal to mass times acceleration. And so it turns out we actually have to find the mass anyways. In order to find the mass, we take the weight and we divide it by g. Because the weight is mass times g, in order to find the mass, we just divide both sides by g. And so we get this. And so the unknown is the applied force by the arms here. So solving for that, we get mass times acceleration plus weight. And at this point, we can substitute this in. We get weight over g times a plus w. And now plugging in the knowns, which are the a here, we just found that earlier, into here, and then the weights given in the problem, we can solve this and get an applied force of 763.4 newtons. And that's the final answer.